Finding the data and tools for exactly the purposes and use cases you're searching for is a key issue, especially in decentralized and very large data ecosystems. In this presentation, my colleagues Justin Dex from MSG, Johannes Demer from ASCS, as well as myself, Rico Auerswald from Fraunhofer-IVI, wanted to show you not only why metadata search matters for both sides, the consumer as well as the data provider side, but also present you our technical approaches we are currently working on and how they will be implemented and embedded in our data ecosystem, as well as our marketplace in the PLC AAD project. For that, we structured our presentation in a way that I will start with a short motivation about why we are doing this, what our use cases are, as well as I will explain how the technical demonstration part will actually work from a user perspective. Justin then will show you how the actual implementation will work and demonstrate that. And at the end, Johannes will give you some ideas about the next steps and what we will do with that, how we go on, and how this all will be implemented together as a whole working ecosystem at the end. First of all, I want to start with the motivation and how our part, metadata search, embeds in our overall architecture of our ecosystem. So why does metadata search really matter? So imagine you're working around a physical marketplace and you want to buy a specific product but have no clue where to exactly find this. So you're walking around, going from each and every booth and just asking over and over again if they actually have what you're searching for. This is very cumbersome, and you're really asking, do I have to do this? And the question is, how could I prevent doing this? And of course, the solution is inherent in extensive and precise metadata, which actually explaining where to exactly find what you are searching for. And also from the provider perspective, it's quite similar. You want that very large user group or potential customers find your data or service or tool offering quite easily, and that they have a good picture in mind what actually your offering delivers them. But on the other hand, for a provider, it is an effort to generate metadata, especially extensive metadata and very domain-specific metadata. And now just imagine that the provider not only want to participate in one data ecosystem, but in multiple ones. And maybe all of them have proprietary metadata description formats and schemas. To prevent this, that a provider have to, for every ecosystem, generate own metadata, we wanted to use as much as possible of integrate existing metadata standards. And we have, of course, found some of them and already using and implemented them, but we have not found like one fits all metadata standard because we have a very heterogeneous metadata and data landscape within our project, in our ecosystem. So having specific data for sensor, for scenarios, for map information, road infrastructure, a lot of stuff going on. And yeah, there's not only one domain-specific metadata standard which fits all of those data categories. So at the end, within our project, we have to handle multiple schemas, more or less, for each and every data category, but also we have achieved to use some metadata standards for multiple data categories. So one example, to show you our schema handling also later in the demonstration. So on the one hand, we have test scenarios. Just imagine some parts of the test scenario we want to or we are able to describe with the set level semantics of SRMD, like the SSP traceability aspects. But for the actual scenario content, we could use ASAM open label as metadata standards. So we describe our scenarios with a combination of multiple standardized metadata schemas. Now let's just imagine we have sensor data as a separate data offering. And here we could use, again, some information parts from ASAM open label, for example, the environment conditions. But of course, open label fits not all the necessary metadata for sensor data. It's not the full purpose of it. But for other aspects, we could use other schemas. And for some of them, no standard will fit. So we have to create our own, like, for example, the measurement setup, which is in some parts possible with the set level semantics, but needs some extensions. So at the end, we achieved to implement in our federated catalog a schema handling which enables us to host and manage multiple metadata schemas, providing us a lot of opportunity and flexibility in compose multiple metadata schemas for our data categories. Before we getting into more details how we actually solved those issues, we wanted to show you how the components which we need and use for our metadata search are embedded within the overall architecture of our PLC AAD data ecosystem. So for the metadata search, the probably most important component is the federated catalog. With the help of the federated catalog, you're not just only able to just store the metadata, meaning all the self-descriptions about the service offerings we want to share in our ecosystem, but you're also able to search through it, executing search queries, which helps you as a data consumer finding what you actually want to use. And you can do this via an API, but as well over a marketplace application, which works in our project as front end for the GaiaX federated catalog. From a data provider side, now the question is, how do I get my self-description into the federated catalog so that someone can search and find it? And for this, I would definitely recommend to listen to the following presentation by Maria from TU Berlin. She will explain you this in much more details. For right now, I think it's sufficient to understand that the self-description within our project can be imported with the help of an extension of the Eclipse Dataspace Connector, with which you can at first store the self-description in our blockchain and metadata nodes, and from there they are gathered via an interface and stored in the GaiaX federated catalog. Okay, now we want to get into more details around our approaches for the metadata search in our project. And for that, we prepared a technical demonstration, and I want to explain you the most important features of this minimum viable product for the metadata search. You can have a look at our MVP from two sides. So on the one hand, from a user perspective, we try to choose the most easiest way of generating and providing metadata for your service offerings. That means that we want to have only one metadata template for each and every data category we support in our PLC AAD data ecosystem. So having one template for HD maps, for test scenarios, for the environment, and so on. That means from a perspective of, for example, an HD map provider, you have OpenDrive map data you want to provide in the data ecosystem, and now you generate metadata following only one metadata template, which is composed maybe out of multiple schemas. And this is now more the under the hood part, the ecosystem perspective, which is a bit more complex. So first of all, we have the schema handling. So we have multiple schemas for different purposes in our ecosystem, and we have to manage those, import those, change them, and combine them. Meaning we have maybe, of course, the schemas coming from the GaiaX ecosystem, which are for service offerings, for example, more general information. Then we have domain-specific metadata information, be it standardized from OpenLabel, for example, be it like the missing pieces we are not able to express with already existing standards and also not with GaiaX, then with proprietary schemas for our PLC AAD project. Now they will be combined for every data category in a sensible way. So meaning, yeah, taking some parts from proprietary, some parts from standardized, and on top we always have the GaiaX schemas. And they will composed in one template. This is called a shackle shape. Justin Dex will explain you what this is in just a second, per data category. This approach will not only enable us to be very flexible with the expression of single data categories, but it will also enable us to combine and link multiple data categories with each other, especially if they are sharing the same concepts, same metadata attributes. For example, you have test scenarios and you are describing them with OpenLabel and saying, okay, those test scenarios should be executed under those environmental conditions. And you might have also measurement data from real world test drives, and you are expressing them also with concepts of OpenLabel. Then if they share the same environmental conditions, you might want to combine them, at least find them in the same search or relate them to each other, or you can already combine them as as a product bundle, for example. Now, Justin Dex will give you more technical insight how we achieve those features, how the processes are working. So I'm very happy to now hand over the stage to Justin Dex.
Yeah, thank you very much. My name is Justin. I'm from MSG, and I will now introduce you to our technical architecture. So I would like to start by introducing you to the basics of our technical architecture, or in other words, Shackle and the federated catalog. Because whenever you upload a self-description into the federated catalog, it applies a specific process, which starts by extracting claims from the self-description and validating these claims against the shackle shape. It then checks the signatures of the self-description and uploads it, if everything is fine, into the federated catalog. Specifically important for our implementation are the steps number 2 and 3, so extracting claims from a self-description and validating these against the shackle shape. Because shackle shapes in general, or shackle files, set requirements for RDF files. So we can ensure that they comply to a specific schema, for example. And we also brought an example for a shackle shape on the bottom left of this slide. In this case, it's the shackle shape PLC scenario data resource shape, and it has the type node shape, which just specifies that it's a shackle shape. And it applies to the target class scenario data resource, which means whenever you upload a self-description having the type scenario data resource or describing the type scenario data resource, this shackle shape will be applied, which means the federated catalog will check if the uploaded self-description conforms with the shackle shape. Within the shackle shape, we can specify different properties that the self-description must contain. In this example, we have the property name, the property description, license, owner name, and scenario created date. And what you can also see here is that we have these properties from different ontologies. So the first three properties are from the GaiaX Trust framework, and the fourth and fifth are from the open label ontology. So the benefits of using this process, using the federated catalog or shackle shapes in our implementation, are basically three core points. The first one is that we can implement a dynamic search based on these properties. It doesn't really matter if it's for products or services. Whenever you describe something in your ecosystem by using a self-description, we can dynamically search for these properties in the self-description itself. Because we know that when we have this shackle shape, the self-description will just be uploaded if it conforms with the shackle shape, and which means that it contains all the properties that are listed here. We can also validate metadata of uploaded self-descriptions. That's basically what I just mentioned. So we can ensure that the metadata really fulfills our expectations. And we can combine properties from different ontologies to describe the metadata, just as we did it with the GaiaX Trust framework and open label ontology. Now on this slide, you can see the technical architecture more in detail. And what you can especially see is these three fields. So we have one search field, one shackle shape field, and one search domain field. The search term is basically just the keyword you want to search for. The shackle shape is the regarding shackle shape of the resource you want to search for. In our case, the resource would be a scenario. So you select the shackle shape for a scenario. And the search domain is basically what exactly you want to search for. So in this example, we would have the search keyword MSG, and we want to search scenarios, and we want to search scenarios where the owner name is MSG. And on the right side, you can now see the backend of our implementation. So basically everything is based around the GaiaX federated catalog, and the GaiaX federated catalog contains two databases. One Postgres database, which contains all the ontologies and especially the shackle shapes, which are pretty important for our implementation, and one Neo4j graph database, which contains the self-descriptions or especially the claims of these self-descriptions. So basically the content of the files or the metadata of the files. This federated catalog is connected to our metadata search frontend. So basically the federated catalog provides the backend for the frontend. And the frontend is just the interface to the user and provides the three fields I've already explained on the left side. And in the next slide, I will now show you a small video of our implementation and how you can search for these components in practice. So far to our technical architecture, and now I'm going to demonstrate you how we practically implemented all the tools in our frontend. Now I'm going to show you a little demonstration of our frontend. This is the landing page where you can basically log in with your GAIA-X credentials. This is by now just a simulated login button, which will probably be compatible with the SSI solution of our project in the future. And now here you directly get into the searching mask. And these are the three fields I referred to earlier in the presentation. We can just have an example. We could, for example, search for MSG as the provider of the scenario data resource. Here we can select the regarding shackle shape. In this case, it's this one. This is just a list of all the shackle shapes that are available in the federated catalog. And you can see that now the search domain is dynamically filled with the content of the shackle shape. So if we take another shackle shape, for example this from the bullwhip effect, you can see that there are different search domains. But in this case, we want to search for a scenario having MSG as the owner name. And when we press the search button, we can see that we get a list of scenarios that are all provided by owner name MSG. We could obviously just search for scenario data resources in general without providing any further criteria. In this case, we would get just all of the scenarios. In this case, we have 5 mocked up scenarios in the catalog. And that's basically it. So we can also search for owner name, maybe something like Fra, containing Fra. This would be scenarios from Fraunhofer especially. In this case, that's the owner name again. And we could also go to the detail page when we have such a scenario. So in this case, we found a scenario. We have here 5 fields describing the scenario a bit further. And when we go to the detail page, we get all of the claims from the self-description. For example, this description field that wasn't provided in the search field before, but is now available in the detail page. And we also have some related resources, unfortunately not to this scenario, but this could in the future be used for bundling different scenarios with different map data, for example. And we have this contract and download button, which will start an EDC transfer process.
Hello and welcome also from my side. My name is Johannes Demer. I work as a scientific project manager for the Automotive Solution Center for Simulation. In this project, it was one of our goals to create interoperability within different ecosystems and to make the search as user-friendly as possible for all roles. Thanks to the previous speaker Rico and Justin, now we have a good overview of technical architecture and the developed features as well as the functionalities. We will now go deeper into the metadata onboarding process and what further development we have planned. We learned already that the federated catalog is a key element in our architecture, but how do we bring our metadata therein? We knew that we need therefore ontologies, shackle shapes and self-descriptions. But how does these work in details? So we have a lot of questions, but we will answer them now step by step. Ontologies are a content framework for structuring and exchange of the metadata, and we are uploading them into the federated catalog. They are community defined, and within the same community we defined before metadata and metadata groups. All these was managed or is managed in our ontology management. The shackle shapes are a verification and source specification for content and correctness, and they are also community defined. The self-descriptions are generated by using ontologies and shackle shapes. And they are product and service descriptions with additional domain-specific metadata. They were created from the data provider or the service provider. How does that work in detail? So the data and the service provider, they have assets. They automatically extract metadata. The metadata is compatible with what is already defined there in the ontology management. So then these metadata is uploaded or into the self-description wizard, and the self-description wizard is then generating a self-description. Having that, we can then upload and check it to the federated catalog. So it was automatically checked by uploading it into the federated catalog. And Justin already described this process more in detail. So that's all of the magic behind the onboarding process of the metadata. In the next agenda point, I will explain more what we have planned in the future and give an outlook what is coming soon. So what do we have planned for the future? We will, on the search engine, we will update that and make it more user-friendly, so you will have in the future there search routines which are product or ODD driven. From the ontology file side, we will finalize our metadata groups and domain-specific ontologies, and we already started to define metadata for product bundles and transfer them also into ontologies. In the metadata and self-description area, we will further develop our automated metadata extraction and generation tools, and we will also integrate our self-description creator into the overall project architecture, so that repo is already open source and public, and you can find it on the link below. So feel free to try it out and hopefully give us some feedback, some good feedback. The shackle shapes in that area, we will create one community coordinated shackle shape per product category. So there will be only one shackle shape for HD maps in our ecosystem, for sensor models, and for scenarios. And hopefully, because we will make them also open source, other ecosystem can adapt these shackle shapes, so we are then interoperable with them. Coming to the outlook, it's really important for us to be interoperable between ecosystems and data spaces. We think we can only achieve that by using community-defined ontologies, shackle shapes, metadata, and metadata groups. So to be Gaia-X compliant or interoperable, we're using the Gaia-X core ontology and enrich that by domain-specific metadata. We initialized a community-based governance model for that for the maintenance and extension of these shackle shapes and ontologies. And therefore, we create a repo in our GitHub, and this repo will very soon become open source, then all of you can try it out. I already put the link of the repo below. We also will transfer the ontology management into OpenMSL to ensure maintenance beyond the end of our project. Thanks a lot for your attention. If you have any questions, write it into the chat so we can answer that in the Q&A. And you can also reach us anytime on the contact details below. And with that, I'm giving back to the moderator. Thanks a lot.